Hello, Einstein. Welcome to our first SHSAT question of the week. Are we ready to begin? Let's go for it. There are 10 teams in a league, and each team plays every other team exactly once during the season. How many league games are played in total? If I'm like most students, what I'm going to do is probably assume, well, there are 10 teams. So if I'm, say, the Giants, and I have to play all 9 other teams, that means I have 9 games to play. So that's 9 games for me, the Giants. And then whoever's the Cowboys, they're going to have 9 games as well. And so on down to team 10, whichever team that is. Let's call that the Eagles. We want to put them as far away from number 1 as possible. So they'll have 9 games as well. So if we have 10 teams, each having 9 games, that's going to be essentially 9 games times 10 teams equals 90 games for the league, for the whole season. And that would be the most popular answer. Unfortunately, it's the wrong answer as well. What? How could that be? Why is that the wrong answer? My logic seems pretty foolproof. So why is that wrong? We can see in the following table, we've overcounted the number of league games. For example, Team 1 plays Team 2, that's 1-2, that's 1 game. Team 1 plays Team 3, that's another game, 1-3, and 1-4 is a game, 1-5, 1-6, all the way up to 1-10. So there are 9 games for our Team 1. Okay, so far so good. That was our original logic. The only problem comes when we go to Team 2. Team 2 plays Team 1, so it's 2-1. But wait a second. Is a game with Team 1-2 and 2-1 the same thing? In fact, it is, because in this case, it doesn't matter what order I display them in, it's still the same game. It's Team 1 versus Team 2. So that means we've already counted this scenario, and we don't need to count it again. We can X that off. And the others are unique still. 2-3, 2-4, 2-5, 2-6. Those, of course, did not appear in our first set of count in column 1 for Team 1. So that means we've overcounted by 1 game. So we don't have 9 unique games from Team 2. We only have 8 new or unique games for Team 2. Because we've already counted that 1 game between 1 and 2 in the first column, the count for Team 1. So we overcounted by 1 in that case. Okay, let's move on to Team 3, see how that works out. Well, the first game is 3 with 1. But wait a second, didn't I already count that game as well? 3-1 and 1-3. Again, order doesn't matter of the teams in this case. So 3-1 is the same as 1-3. I can eliminate that. I've already counted it when I counted the first team. My next game on the list is 3-2. But wait a second, once again, I counted that in the count for Team 2. There it appeared as 2-3, but that's the same as 3-2. It's Team 2 versus Team 3. So I have to eliminate that because I don't want to double count that occurrence again. Game 3-4 would be next. That is unique. We didn't express that before. 3-5, 3-6, 3-7, and so on, all the way up to 3-10. So, in essence, we don't have 9 games for Team 3. We have 2 less than 9 games because we had to eliminate 2 games to make sure we're not double counting them. So we only have 7 games. So is anybody noticing a pattern here? Every team we count, the number of unique or new games in that count is not 9 for every team, but it's decreasing by 1 every time because we've already picked up a duplicate. Let's just look at 4 to double check that. So 4-1 appears in 1-4. I can eliminate that. It's double counted. 4-2 appears in 2, 4. So I can eliminate that so I don't double count it. 4, 3 appears in 3, 4 already, the count for team 3. So I can, whoops, I didn't need to eliminate that one. We can eliminate that one for team 4. So I've got 3 so far that have already been counted. And 4, 5, 4, 6, all the way up to 4, 9, those are unique new games. So it's not 9 for team 4, but it's 9 minus the 3 games already counted, or 6. Well, our pattern's holding. Likely it's plus 5, plus 4, plus 3, plus 2, plus 1. And then finally, as we get to team 10's count, we'll notice I've got 10-1 was already picked up as 110, 10-2 is picked up as 210, 10-3 is picked up as 310, 10-4 is 410, and finally 10-9 was picked up in the 9th row as 9-10 would have been the last one. So we can eliminate every single game. We've already counted them for team 10, so there is 0 new or unique games played. We have a summation of consecutive integers 1 to 9. If you add it all up, it turns out to be 45. And an easy way to add this up, rather than putting them all in a column and adding them together, is realize this is the sum of consecutive integers 1 to 9. And that sum is always consecutive integers 1 to n is n times n plus 1 over 2. In this case, n equals 9. That's our final nth term in the series. So that is 9 times 9 plus 1 is 10 divided by 2, which equals 45. It's a much faster way to get to the sum, and it's a good little equation to know for the exam, especially when you get to sequences and series. So that is the correct answer, and hopefully you can now see the original answer was incorrect, but it was double counting a whole host of games. In fact, it was double counting all the games, so the correct answer was exactly, in this case, half the original calculated answer by most students. It's 45, not 90. A potentially even easier approach to solve this problem is to look at it the following way. Every game is a pairing of teams. So there are 2 teams in every game. If every team plays every other team exactly once, the question we're really asking when we ask how many league games there are is how many pairs can we create from 10 unique teams? And of course, there are no repeats of teams. Well, answering that question is just answering how many ways can I choose the first team and how many ways can I choose the second team. And since they're independent events, I will multiply those 2 results to get my total number of ways to put 2 teams together for a game. So at first, and students get a little confused if we begin from the last logic, where we started as 1 team and had 9 other teams. I'm going to pretend we're outside of the teams entirely here and looking in at the 10 different teams. And I'm going to choose one of those 10 teams. So I can choose any of those 10 teams, which means there are 10 ways I can choose the first team. The second team, given that I've chosen one of the teams already, leaves me 9 choices left for choosing my second team. And that result is 90. Well, hold on a second, that looks like the original answer we had, which you told us was wrong. True. However, we have to take note again of our overcounting. In the last example, it was 1-2 and 2-1 paired. In this case, we could think of it as Giants playing the Cowboys and Cowboys playing the Giants. That's essentially the same game. It's the same 2 teams on the field, only we counted both options, just as we did before when we do that. Because essentially what we've done here, whether you realize it consciously or not, is what we call a permutation. It's a fancy word for the simple calculation or logical approach you just took. And the permutation is a means by which we can, among n unique items, choose r distinct items. So in this case, we're choosing out of 10 items, we're choosing 2, just a pair of teams for every game. And that result is n factorial over n minus r factorial, which, if you notice, that's 10 factorial over 8 factorial, so the 8, 7, 6, 5, 4, 3, 2, 1s cancel out, and the result is just 10 times 9 in this case. And if you need to see that further, I could put that up here, 10 factorial over 10 minus 2 factorial, which is 8 factorial, equals 10 times 9 times 8 times 7, etc., all the way to 1. And 8 factorial is 8 times 7 times 6, all the way down to 1 in the product. And of course, all these terms that are in the product on numerator denominator cancel, and the end result is just 10 times 9. So essentially what we did, we used our logic to calculate the number of ways we could select 2 teams together out of the 10 unique teams in our list. And what we were really doing, not necessarily realizing it, is we were doing permutations. We were counting the elements selected as though the order between those elements selected matters. But we know that's not true in this case. The order does not matter between selected items. And as with typical permutations and combinations, a combination is a scenario where the order doesn't matter, like Giants, Cowboys, Cowboys, Giants. So those are all fancy words, but what it means is we have one extra step to take care of whenever we take this logical approach. We have to ask ourselves, is this a permutation where the order of the elements selected matters, or is it a combinations problem where the order of selected elements does not matter? In this case, we know it's a combinations. The order does not matter. Therefore, we have to add the extra term in the product of the denominator, which is the r factorial. And essentially, that's the number of ways to arrange that many items you're selected. In this case, r equals 2, so we're dividing by 2 factorial. So our result becomes 10 times 9 divided by 2 factorial, which equals 2 times 1. 10 times 9 is 90. So that's just 2 as well in the denominator. So 90 divided by 2 is 45. And that is our correct answer. So essentially, you could look at this question as asking, how many ways can I create pairs or select 2 teams out of 10 unlike teams? And the answer in this case is 45. And the one nuance is to differentiate, as we do with this logical approach, and many students forget to take the last step, is to differentiate between permutations and combinations, which is simply to ask the following question: does order of the selected items matter? If it matters, that is your answer, but in this case, that's not true. So that is your answer because you have to divide by r factorial. And be careful, it's not always dividing by 2 to correct the overcount. If there were 3 items selected, say 3 teams were defined as a game, we would have to divide, we're selecting r equals 3, we would have to divide by 3 factorial, which is essentially 6 to reduce the overcounting. So that is another way to think of the problem and get directly to the answer of 45 and perhaps even more quickly. I hope that helps. Thank you for your help, Einstein. And everyone else, have a great day.